Hey everyone, welcome back. This video is going to be a little bit different. Since my sort of main game has the player walking through a field and it has flowers and stuff, I really wanted to see how far I could push that in the Godot engine, at least on this computer. So normally I'm developing on my desktop, but I've moved over to my laptop here because my laptop is a lot less powerful, and I really wanted to see what the performance would look like on my laptop if I absolutely just destroyed the screen with particles and like sprites and animations and stuff like that. And this is my sort of first stage of experimenting with this, and I think it's actually turning out pretty well. So you're looking at a ton of instanced scenes, the flowers themselves, and each one of those scenes has shaders attached to it, which is why you can see them all waving, and they also have some collision and some animation attached. So basically when I'm walking across the scenes, the flowers, it is triggering the little animation that makes it sway to the left or to the right and then come back slowly. So I also tried something new when trying to actually add these flowers to the scene, because there's no way I could do this by hand. I think the current number of flowers is over like 8,000 or something like that. But I was looking around on YouTube for some tutorials about how to instance like a ton of scenes or a ton of sprites programmatically, and I came across instancing using Tilemaps, which is pretty cool. So I'll show you how I did that. But otherwise, let's take a look at how this works. And overall, I'm kind of impressed with the fact that it's running. Also, this laptop has a Geforce MX150, which is pretty low end, I think, when it comes to gaming. So I'm actually going to switch it over to the integrated graphics on this laptop and see how that works as well, because I'm actually kind of encouraged at the fact that it's running it all like this on the MX150. So we'll see what the integrated graphics does. Anyway, let's take a look at how I did this, and stick around. Alright, so if you can hear that, that is the laptop fan. It goes crazy whenever I actually run the scene, which makes total sense. But this is what the scene itself looks like. So I basically just have some sort of big tree sprites that I drew, and so it's not too complicated. And I have the same player character that I use over in my regular devlogs, just to actually add a character that I can move around and attach a camera to. And then I have in my main scene here a sort of little FPS label, so you can actually see what the performance is. That's sitting in a canvas layer over here, and that's pretty much it. So the main thing that I'm doing here that I've never done before is, via a tile map, is instance all the flowers on the tiles themselves. So if I click on my tile set over here, I basically just created a super basic tile set, and it's actually 128 by 128 tiles, but I'm just using small pieces of those tiles just to get something sort of prototyped in here. So each one of the pieces is 32 by 32. So if I click back on my tile map, you can see over here the cell size is 32 by 32. So each one of the flowers is being instanced more or less in the center of one of those 32 by 32 tiles. So it's super convenient. So I basically can choose what to instance on each tile. And as I said, I found that in a YouTube video, but I'll show you my own implementation. So if I click on the tile map over here, basically I have sort of preloaded two different kinds of flowers, and I'm only really using the white one at the moment. But the tiles themselves have a couple of methods that you can use to get their position. So the position of each tile that actually has something in it can be found with this map to world method associated with the tile map, which is really cool because once you get the position, you can put things right where that tile is. So as you're painting tiles on here, basically, you're painting exactly where the flowers are going to go. So it just makes it really useful for really big scenes with a ton of stuff that you would otherwise not be able to do by hand. And it's also useful because I don't even know if this laptop can handle looking at like all of them at once here in the editor. So it's good that they only appear when you instance or when you start the game, and they only really appear within the bounds of my camera attached to my player here. So if I go back to my script, really basically, so for I in range 0, array size, and the array is another method that the tile map class has. Basically, the getUsedCellsById returns an array of the cells that you're looking for. So if I click on my tile map again, and then on tile set, where's my 2D window here? Tile map. If you go into your little sort of tile browser here, you can see the IDs associated with each tile. So this slightly darker green one here is 0. This slightly lighter green one is 1, and I'm using the ID 1 to tell the script to instance a flower. So it's iterating through the array of all of the cells that have the ID 1, getting their position, and then instancing a scene, in this case the flower, at that position. And I've actually sort of randomized it a little bit because the position of the cell or the tile is actually found in the upper left-hand corner, but I want the flower to appear in the middle. So since I know the tile is 32, I sort of randomized it a little bit and said, okay, instance a scene at the upper left-hand corner of the tile plus anywhere from 0 to 15 pixels in the X direction and the Y direction. So every flower is more or less in the center of the tiles. So that's how it works. And I know I'm speaking really fast, but it's overall relatively simple to add things to the scene. And I've been pretty impressed with the performance. So let's check that one more time using, as you can see, the sort of dedicated graphics on this laptop, which is the Geforce MX150. So as you can see again, on the MX150, we're getting around 90 frames a second. And actually, it's faster if I'm not using OBS. And if I'm not using OBS, it's like around, I've seen like 150 frames. So that's actually pretty impressive for this amount of stuff. And one thing I forgot to mention, I'm actually hiding everything that's outside of the sort of visible area on the screen. And let me quickly show you how I did that. So in my flower scene itself, I have a visibility notifier, and then attached to the sort of flower scene script. In the visibility notifier, I've set visible to false when it's not visible, and set visible to true when it is visible. And also, all of the flowers are initialized as set visible to false. So it doesn't actually show everything. And I think this does have an impact on performance. I know the Godot engine kind of doesn't show things that are off the screen in general, just as I think a basic function of a 2D game engine. But I've noticed that actually including that visibility notifier does have an impact on performance. So we took a look at the MX150 performance, which again was, I've gotten up to like 160 without running OBS, and then running OBS was like around the 80s or 90s or even as low as the 70s. But now I'm going to switch over to integrated graphics, and we'll take a look at how that works. So I've switched over to the integrated graphics on this laptop. If we switch over to our little Godot command window, we can see we're running on Intel UHD 620. And that's pretty much as low as you want to go if you're playing games on your laptop at all. So let's take a look and see what the performance looks like here. All right, so here we are in the field with the sort of integrated graphics turned on. And we're getting upper 30s, sometimes upper 40s. And once again, this is with OBS on, so I've tested it out without OBS, and I was getting in the 50s and 60s. Occasionally, so I'm actually pretty impressed that the integrated graphics can handle all this stuff. And I guess this is the performance you can expect while running OBS on integrated graphics on like a pretty basic laptop, I think. So it's actually still impressive, and I have an idea for a commercial game, my first commercial game, that's going to include some effects like this and a bunch of particles and stuff like that. So if it's running this well on integrated graphics, I think I'm going to be okay. And obviously this is without any real sort of optimization done. I think it's pretty simple at this point, but I'm sure there's still things I can do to make it run faster. So hopefully that will improve performance even more. And otherwise, I think I'm overall pretty impressed with the fact that it's even doing this well. So thank you all for watching. This is just a little fun experiment that I was doing, and I hope to see you in the next video. Thanks.